So, how do we make sense of the world around us? It's a massive question, right? But it all starts with something really simple. Just being curious. Today, we're going to break down the nature of science and technology and see how one little question can spark something that changes the entire world. Okay, let's jump right into our investigation. I want you to imagine you're a detective for a minute, and the whole natural world, that's your mystery scene. So, what's the first step? Well, you've got to find the puzzle that needs solving. Just look at this, the aurora borealis. It's this incredible dance of light across the sky. It's beautiful, it's kind of mysterious, and, it almost dares you to ask a question about it. And there it is. That's the question. What could possibly cause something like this to happen? Now, this isn't just some random thought. This right here is the spark that lights the fuse for a whole scientific journey. Because really, that's what being a scientist is all about. They see something they don't get, and they just have to ask why or how. That feeling of wonder you got just about looking at that picture of the aurora, that is a starting line for literally every single scientific discovery. So once our detective has a good question, they're going to need the right tools to find answers they can actually trust. Let's pop open this toolkit and see what's inside. Okay, first tool up, observation. This is all about just using your senses, what you see, what you hear, what you can touch, to gather clues. When we were looking at that aurora, we were observing it, right? We saw its color, its shape, how it moved. That's observation. Next up, you've got the hypothesis. And notice that key phrase, a testable prediction. This isn't just a wild guess. It's an educated guess based on what you've already observed. It's the detective in our story saying, okay, I think this is what happened, and here's how I'm going to try to prove it. So how do you test it? You collect data. And data is just a fancy word for information. Measurements, descriptions, results from a test. It's the evidence. It's the stuff that's either going to back up your hypothesis or, send you right back to the drawing board. Now, the absolute gold standard for collecting really good data is the controlled experiment. This is where you test just one single thing at a time, and you keep everything else exactly the same. That precision is so important. It lets you figure out what's causing what, which makes your evidence super reliable. All right, we've got our toolkit. Let's see how all these pieces actually fit together in a really simple, hands-on example. And you really don't need some multi-million-dollar laboratory to see the scientific method in action. Sometimes a really simple model can tell you everything you need to know. And look at this. All we need is a cardboard tube, some string, and scissors. This just goes to show you that the power of science isn't about having fancy equipment. It's all about the process. Okay, let's walk through this. First, you observe the mystery. You pull one string and another one moves. How is that possible? Second, you hypothesize. You make a guess about how the strings are connected inside. Third, you design your own model based on that prediction. And finally, you test it. You pull the strings. Does it work like the original? If it doesn't, that's okay. You just tweak your hypothesis and try again. And that right there is the scientific method in a nutshell. So you've tested your hypothesis, it works, you've solved it. Case closed, right? Well, not exactly. And this is where the story gets really, really interesting. This is probably the most important part about how science actually works. This quote here is so important. The answers to scientific questions are considered uncertain. Now, that might sound a little weird. I mean, isn't science supposed to be about finding solid, concrete facts? Well, yes, but it's also about being honest about the limits of what we know at any given moment. And here's the reason why. It's because we can never truly know everything. There's always the possibility that new tools, new evidence, or new observations could come along and completely change what we thought was true. Science isn't a book of answers that's already finished. It's a living process of constantly getting closer to the truth. This little flowchart shows it perfectly. Someone proposes a possible explanation. Then later on, new info is discovered. And based on that new info, the original idea has to evolve. It either gets tweaked and modified, or it gets thrown out for a better explanation. It's a cycle, and it's what keeps pushing us forward. So what's the point of all this questioning and testing and refining our ideas? Well, that brings us to our final section, how we put all this knowledge to work in the real world. And that, my friends, brings us to technology. The definition is so simple, but it's incredibly powerful. The practical application of science. Technology is what happens when we take that scientific understanding and use it to build things, create tools, and solve everyday problems. And this slide just shows that relationship perfectly. On one side, you've got a telescope that's a tool for pure science, for just learning new things. On the other side, you have a scientist in a lab applying that knowledge to create something new. The easiest way to think about it is this: science is the knowing, and technology is the doing. And that's really the big idea here. This whole cycle we've talked about, from asking a simple question to observing to testing and then finally applying that knowledge, that process is the engine that drives all human innovation. It's how we've gotten everywhere we are today. So let's end on this thought. What science teaches us is that no single idea is sacred, and any explanation can always be improved upon. And that means the world is just full of mysteries, waiting for a curious mind like yours to come along. So the only real question left is, what mystery are you going to try to solve next?